Hello students. Now we are going to see the next concept, that is closure of a relation. Consider this relation R on the set A. Is it reflexive? As you might have guessed, it is not. So how can I make it reflexive? It's very simple. I can make it reflexive just by adding the pairs 2, 2 and 3, 3. Why? Because a reflexive relation has the tuple of the form AA, in which this is true for every element in the base set. So if I add these two tuples to the original relation R, I will make the relation reflexive. So the newly obtained reflexive relation is denoted by reflexive of R, and it is given likewise. Here you can see the original relation is kept as it is, and I've added two more tuples. So now I'm comfortable to define what is a closure of a relation. So closure of a relation R with respect to a property P is the relation obtained by adding the minimum number of ordered pairs to the original relation to obtain that particular property. So what is a property? We have already seen the properties of binary relations, that is reflexive, symmetric, transitive, and so on. So if I want to obtain any property P for the relation, I will do it by adding the minimum number of ordered pairs to make it obey that particular property. So the previous example, this is nothing but the reflexive closure of R. Why? Because I added minimum pairs to R, so it became reflexive. Similarly, I can define the next property, that is symmetric closure. So here the relation on the set is not symmetric. So how can I make it symmetric? Just like the previous one, I will add those pairs which after adding will make the relation symmetric. So if you look closely, 1, 1, symmetric pair 1, 1, 1, 2, its symmetric pair 2, 1 was not present. So I added it explicitly. Next is 2, 2, its symmetric pair is 2, 2. 2, 3, symmetric pair 3, 2, which was present. 3, 1, symmetric pair 1, 3, which was not present. Therefore, I added it explicitly. So now if you observe, the relation R is symmetric. So this is nothing but the symmetric closure of R. Next is, we'll see transitive closure. So this is your relation R. Check if it is transitive, and if not, add minimum pairs to make it transitive. So I'll see first 1, 2 and 2, 3. I can combine them. I will get a tuple 1, 3. Is it present in the relation? No. So I'll have to add 1, 3 in the original relation. Next is 2, 3 and 3, 3. If I combine 2, 3 and 3, 3, what will I get? If I combine 2, 3 and 3, 3, I will get again 2, 3, which is already present in the relation R. Okay. So how do I make it transitive? By adding the tuple 1, 3. So very important note to understand is that you don't actually change the original relation. You add pairs to the original relation. That is nothing but the closure. Don't just write the added tuples in the closure. The closure for any relation will contain the original tuples as well as newly added tuples.